Good afternoon, everyone, and welcome to this Fortum-hosted workshop of Proven Sustainable Radioactive Waste Management, where we explain how radioactive waste management is handled in Finland using our own Loviisa nuclear power plant as an example. My name is Otso Manninen, and I work as Director for Decommissioning and Disposal Services at Nuclear Services at Fortum.
And my name is Antti Ketolainen. I'm in charge of our services to the operating plants and waste management. So I'm a colleague of Otso. Yes, so let's start with a short introduction to our company. So Fortum is a Nordic-based power production, energy production company with the main focus on CO2-free power production forms, namely hydro and nuclear. 52% of our power production capacity is coming from the nuclear, and that is consisted of our fully owned Loviisa nuclear power plant and then our co-owned power plants in Finland and Sweden. In addition to that, we are currently investigating possibilities to expand our capacity. We are carrying out so-called new nuclear feasibility study investigation of the possibilities to build new nuclear either in Finland or Sweden. And then, in addition to that, we are also a service provider. So the expertise that we have developed originally for our own power plants in the operation of those and in the waste management on which this presentation is particularly focused. That expertise which we have over the whole life cycle of a nuclear facility, we also utilize for the benefits of our clients and offer that through our nuclear services business units. And as I mentioned, so today, me and Otso will focus on the back-end part. We will focus on the waste management part. And as a matter of fact, in addition that we are a nuclear operator, or actually due to the fact that we are operators, we are also a waste management organization. We are operating a low and intermediate level waste repository in Finland at the very same site where we have our Loviisa power plant. That's been in operation since the middle of 90s. And furthermore, in addition to that, together with another Finnish utility, TVO, we are co-owners, we jointly own the company called Posiva Oy, which has the responsibility to dispose the spent nuclear fuel of its owners in Finland. And they are at the moment in the commissioning phase of the world's first deep geological repository. And the schedule is such that in the near future, next year or soon, the operation will start at the repository. But yeah, Otso, will you continue on that?
Moving on to the high-level waste management schematic in Finland. So here's the setup. So there are two utilities in Finland, Fortum and TVO, and they both own their own nuclear power plants, of course, and they both have their own low and intermediate level repositories that they own and operate. They're also both responsible for the interim storage of the spent nuclear fuel. And as Antti already briefly mentioned, they are the co-owners of Posiva, which is the spent nuclear fuel disposal company in Finland. So both Fortum and TVO, they take care of their own low and intermediate level waste all the way from waste generation processing to disposal. And then for the high level waste that is spent nuclear fuel, there is a company called Posiva, which is responsible for it. All of these are private companies, and Posiva is jointly owned by Fortum and TVO. Yes, and then moving on to the actual waste management at the nuclear power plant. Here can be seen like a division of the different waste routes or waste fractions that are produced in the control area of the nuclear power plant. Much of it is below the exemption limit, so it means it can be free released, and it's treated in a very typical way. It's going to recycling or to hazardous waste processing, or if it's not recyclable or hazardous waste, it just goes to a landfill. Then there is the part that is above the exemption limit. And then that consists of the low-level waste, which is mainly solid waste, which is packed in barrels. Then there is the intermediate level waste. Antti is going to talk more about it because it's mainly liquid waste that we're talking about. There is also some solid intermediate level waste, which is stored in pools and dry silos at the nuclear power plant before disposal. And then there is the high-level waste, which is spent fuel, and some other high-level waste, small amounts, which is stored in the reactor hall or at the spent nuclear fuel interim storage in the pools. And here you can see the different the division between the different fractions. So as I already told, much of it is conventional waste that goes is free released and goes through traditional waste routes, 96% altogether, and only 4% is something that is not cleared. And as I already explained, half of it is spent fuel that goes into final disposal at Posiva's facility in Olkiluoto, and half of it is low and intermediate level waste that is going to the disposal in Fortum's own low and intermediate level waste repository at Loviisa, and I will come back to the low and intermediate level waste repository a little bit later in the presentation. These are figures from last year. The percentages and the numbers vary a little year by year because depending on the outage and the type of works that are performed during the outage. If there is, for instance, demolition work, that of course produces more waste than if there is like just replacement of some smaller parts. But these are the numbers from last year, and the sort of like scales are similar from year to year.
Yes, thank you, Otso. Continuing actually on that previous slide. So one of the key philosophies, fundaments in our holistic waste management approach is the volume reduction. That's something that we are driven for, that we are seeking for in all of our activities, starting from the waste production, so the plant's operation, all the way to the treatment and then to the final disposal. And why we do it? So it's a matter of safety, sustainability, and cost efficiency. So the less waste, radioactive waste we have, the lower those exposures are to the public and the people working at the site. It's also sustainable. So the less radioactive waste we need to dispose, put underground, the less the environmental footprint we will have. And the cost efficiency. The waste management costs are decreased and the waste disposal costs are decreased the less we are producing the waste subject to final disposal. And furthermore, actually it's also a very beneficial from the public acceptance point of view, especially the sustainability point of view. Sustainability part factor that less we have the disposal waste, it's a good also from the public opinion. And here's a technology that we have developed particularly for that reason, to reduce the waste volume. It's intended to purify the radioactive liquids, and it's called NURES, Nuclide Removal Solution. Originally developed for the purposes of our own Loviisa nuclear power plant, and originally developed to capture the cesium from the radioactive liquids. But nowadays, and after the invention in the early 90s and deployment in Loviisa in middle of 90s, we have developed it further, and nowadays the product family is consisted of altogether 4 products: CS Treat, intended and designed to capture the cesium radionuclides, SR treat for strontium, cobalt treat for CO treat for cobalt, and SP treat for antimony. And here's a simple illustration about the driver of this product. So as I mentioned, the intention, the purpose of the product is the volume reduction. So comparing to other competing or other alternative treatment methodologies, NURES technology is superior. Its selectivity, it's highly selective inorganic material, so its ability to capture the particular radionuclides that it's designed for, it's superior to compared to other alternatives, especially to direct disposal, obviously, but then also when we are comparing it against the evaporation, reverse osmosis, or resin, let's say normal standard resin-based ion exchange materials, which are often organic, because the good thing in the NURES is that it's fully inorganic, which is also beneficial from the final disposal point of view. There are some figures also there on the slide. The NURES was deployed or taken into use in Loviisa in middle of 90s, and we have used that for the treatment of the liquid since then, so that the cumulative amount of the liquids is over 2,000 cubic meters. And what we have reached is that we have reached over 3,000 time volume reduction with this NURES material, and gained a significant cost savings while using it.
Okay, moving on to the repository part that I mentioned earlier. Here you can see on the left-hand side a schematic of the Loviisa low and intermediate level repository. It was commissioned in 1998, and it consists of an access tunnel and a personnel shaft and these vault-type waste caverns, so horizontal waste caverns. There are 3 maintenance waste halls, 1 solidified waste hall, and then these lighter green ones are designed for the decommissioning waste, and they're not excavated yet. They will be excavated closer to the actual decommissioning of the plant. Now we have operating license until 2050, so it's not yet topical to excavate those. But they are already in the design and have been from the beginning. The maintenance waste halls are mainly used to dispose of the low-level waste. The upper picture on the right-hand side is from the maintenance waste halls, where the waste is stored in these drums. And then this solidified waste hall is used to dispose of the liquid waste, solidified liquid waste, and it's disposed of in these concrete containers that you can see in the picture. Also, the small amounts of solid intermediate level waste can be put into the same concrete containers and disposed of. But since the vast majority of the volume is liquid waste, the name of the cavern is liquid waste hall. It's about 100 meters deep, so it's not what you would call a DGR, but it's not near surface either, depending on the categorization by country. Construction-wise, it's very similar to a DGR, although it's less shallow. And then here we have the kind of like a schematic of the principles of how does the waste repository function and what are the safety functions of the repository. So I'm not going to go through it all arrow by arrow. You can read it yourself. But the guiding principles in the design of the repository are to contain the activity inside the containers, to create barriers and to prevent the activity from spreading, to protect the barriers mechanically, like the containers, for instance, to limit the groundwater flow in order to slow down the transition of the activity, and prevent the human intrusion. And this is also where you can see the difference between the low-level waste and the intermediate level waste, because for the low-level waste, we have packed it in the drums, and they're not considered barriers in terms of preventing the activity release. So on the left-hand side, you can see there is no safety function on the drums. On the right-hand side, for the concrete containers, they act as a barrier that contains the waste and contains the activities from spreading. And then there is the cavern that protects the containers mechanically and prevents them from breaking down further, slowing down the release of the activity. And here we have a map of projects that we've done abroad. So until now we've been talking about what we've done at Loviisa and what we've done at Finland, but we're also a service provider in addition to doing our own, dealing with our own waste. So we have done, for instance, safety cases for our own repository, but also for TVO's repository on the west coast of Finland. We are also heavily supporting Posiva when we have been supporting them throughout their project, building the world's first DGR for disposal of spent nuclear fuel. And lately we've been especially supporting them in the commissioning related activities, as they are planning to commission the facility next year. And for instance, we're writing them manuals and instructions related to the operation and maintenance of the facility. Outside of Finland, I could lift up, for instance, the support that we're doing for BGE in commissioning their low and intermediate level waste disposal facility, Konrad, and there we're supporting them with the commissioning of the facility. Also, an interesting project inside Finland is the FIR1 research reactor decommissioning project. While it's not strictly disposal, it's an interesting project because it was a turnkey delivery where we were planning the works, executing the dismantling, and we also took care of the waste. So we took all of the waste, apart from the spent nuclear fuel that was returned to US, and we took it into our own repository at Loviisa and disposed of the waste. So that's the kind of like turnkey, full package decommissioning project, which is quite unique worldwide, I would say. Antti, you can maybe share a few words about the liquid waste references that we've had.
I will move on this side of the map, so we'll cover the whole map here. So as also mentioned, this map illustrates a certain selected customer cases that we have on the waste management sector. I could mention a couple of examples of this liquid waste treatment expertise, and as particularly on the NURES deliveries, NURES system implementations that we have carried out during the past few years. Let's start from the Japan. Maybe one of the most famous client reference cases that we have is from Fukushima Daiichi, so the accident power plant site there. They have used in their ALP system our NURES treat material, so cesium treat and cobalt treat, SP treat there in the ALP system. And the volume reduction or the decontamination factors that they have reached out are significant with our materials. Another example, Loviisa, of course, I mentioned already. If I take another example from the operating power plants, Paks power plant in Hungary have been our customer and have utilized a cesium cesium removal solution in their power plant since middle of 2000. So we basically deliver a treat material for them annually. On the decommissioning side, so in many decommissioning projects, there are often a case that there are a lot of liquid stored at the power plants that need to be taken care prior to dismantling activities can be started. Couple of examples from the Germany. Grafenrheinfeld power plant and Gundremmingen power plant. In Grafenrheinfeld, we delivered a complete modular and mobile NURES system, which consisted of columns with the different treat materials in series. And with this system, which was installed in 1 year, it took them 1 year to treat 1,300 cubic meters of radioactive liquids. And they did it with 12 liter columns. So the volume reduction that they gained, since then they will dispose these columns to a 1 cubic meter size of the disposal container, they reach over 1,000 volume reduction rate, which is significant also from the cost point of view, as you can all imagine. And then the last example that I would still want to mention is a much smaller case. So it's kind of showing the scalability of the solution. We have delivered to Sweden, Studsvik, a laboratory scale NURES treatment system. Pretty much similar, based on the similar idea than the larger Grafenrheinfeld solution that I just described. But the size of the system is so small that it fits in the standard cupboard. So very compact solution that can be used to treat small amounts of liquids born in the laboratory operations. But yeah, and besides these, there are plenty of references that from the customers that we have been provided the services and our solutions during the past couple of decades.
Yeah, and we're happy to, of course, talk more about this after the session with you. But moving forward to the key takeaways of the presentation, we have managed to take care of the big picture of the sustainable waste management and managed to organize the waste management in a sustainable way in Finland. And a large factor in this is that we are responsible for or our responsibility covers the entire lifetime of the waste. And it's set up in these private companies. So we are responsible for all the low and intermediate level waste, and we are the owners, direct owners of Posiva, who takes care of the high level waste.
Yes, and as I have already several times mentioned, one of the fundamentals or one of the key principles in all our waste management activities is the volume reduction and the benefits that we can gain out of that from the safety, sustainability and cost efficiency point of view that cannot be underlined enough.
Yes, we have built waste routes and for final disposal. The low and intermediate level waste disposal is already in operation and has been in operation since the 1990s. The DGR for the spent nuclear fuel is just about to be commissioned and it's in use, and that will cover all the waste that we're generating.
Yes, and all this experience, these proven solutions that we have originally developed for our own facilities, we also serve as a service for the benefits of other stakeholders of the nuclear industry through our nuclear services business unit. And with these words, I want to thank you all for the attention of this our presentation and invite you to come to discuss further on this topic with us in the QA session, and then after this session, I think right away, so or actually 5.
It's at 5 p.m.
5
yes.
p.m. We are hosting a cocktail reception on our booth at G48. So hope to see you all there as well.
Yes.
Warmly welcome.
Thank you.